Okay, let's take a look at the next example. And just a reminder that anytime we have a radical form, we need to convert that into exponential notation. And anytime something is on the denominator, we need to move it to the numerator before we differentiate. So let's take a look at this example here. I see we have a square root of x, and that square root of x, we're going to rewrite that as x to the 1/2 power. Same thing here, square root of x, we're going to write that as x to the 1/2 power. Rules of multiplying exponents: anytime you multiply the same base, we add their powers. So um, because we're multiplying a base of x twice, we're going to combine that under a single base, and we're going to add the exponents. So 4, we're going to write that as 4 over 1 plus 1/2. And then here on the denominator, same thing, because we're multiplying the same base, we are going to add the exponents. So we have x parentheses 2 over 1 plus 1/2. Now we do need a common denominator. So if we have 4 over 1 and we need to have a denominator of 2, then in order to convert the 4 over 1 into a denominator of 2, we're going to multiply both the numerator and denominator by 2, thus making it 8 over 2. Same thing with the 2 over 1. We have a 2 over 1, and we need to get a denominator of 2. So we're going to multiply both the numerator and denominator by 2, thus making it 4 over 2. And if you think about it, 8 over 2 is the same thing as 4 over 1. It's just a different way of writing it, so we can have the common denominator. Okay, so we have 8 over 2 plus 1/2. This gives you negative 2x to the 9/2. And then 4 over 2 plus 1/2. This gives you x to the 5/2. Now, the x to the 5/2 cannot be on the denominator, so to move it to the numerator, we're going to make the exponent a negative. Anytime we move from the denominator to the numerator, the exponent becomes negative. So this is just a setup to the differentiation process. Now we can do our actual differentiation. So in the actual differentiation, the 9/2 comes down. We have negative 2 times 9/2, and we subtract 1 from the 9/2. Same thing with the negative 5/2. It comes down, so we have negative 6 times negative 5/2, and then we subtract 1 from the negative 5/2. Once again, let's get a common denominator. So we have negative 9 over 2 minus 2 over 2. And notice that these two divide to be 1, so we can cross those out, and we just have a negative 9x. Here, 2 goes into 6 3 times. We have negative 3 times negative 5 is 15. And once again, the 1, we're going to rewrite that as 2 over 2. Then let's combine our numerators, because now we have a common denominator. So we have negative 9x to the 7 over 2 plus 15x to the negative 7/2. Now we're not quite done, because we need to write these in radical form and with no negative exponents. So the denominator is the root, so we have a square root of x to the 7th. Here, we move the x to the negative 7/2 to the denominator, becomes x to the positive 7/2. But once again, we need to write that as a radical form, so that'll be the square root of x to the 7th power. That was a long example, so think of any questions you may have, look over this again, and come to class prepared with some questions. Okay, find the derivative of this term. Now, there's a little trick we can use. Anytime you divide multiple terms by a monomial meaning one term, we can split those all up. So we're going to divide every term on the numerator by x cubed. Just a quick reminder of the quotient rule for exponents. If you divide the same base, we subtract the powers. So 5 minus 3 is 2, we get negative 3x squared. 4 minus 3 is 1, so we get 4x. 3 minus 3 is 0. Now, x to the 0 power is 1. In other words, the x cubed over x cubed, we just cross those out. So we have negative 6. 2 minus 3, we have an x to the negative 1. And this is like an x to the first. So 1 minus 3, we have x to the negative second. Okay, now we're going to differentiate. So we do our normal differentiation procedure. We bring the 2 down, so we have negative 3 times 2. We subtract 1 from the 2. 4x, there's an exponent of 1. So we bring the 1 down, and we subtract 1 from that. The derivative of any constant is 0, so that's just going to be 0. Here we bring the negative 1 down, so we have 2 times negative 1, and subtract 1. Negative 2 comes down, we have 8 times negative 2, and we subtract 1. So if you simplify that, we get negative 6x, 4x to the 0 power, minus 2x to the negative second, and minus 16x to the negative third. If we write all the negative exponents in using positive exponents, that you have to move to the denominator. So our final answer is negative 6x plus 4 minus 2 over x squared minus 16 over x cubed. Okay, next we're going to talk about the product rule. The product rule is product rule is used, it's late, sorry. The product rule is used when you multiply two different terms that can be differentiated. So the product rule says this: if you take the derivative of f of x times g of x, it equals to your first term f of x times g prime of x plus your second term g of x times f prime of x. Okay, so it's fg prime plus gf prime. So before we can do this, we have to designate one term as the f of x and one term as the g of x. So in this case, my first term will be my f and my second term will be my g. So according to the product rule, my derivative, so I'm going to say y prime, is equal to f times g prime plus g times f prime. What I do recommend is that you organize your information. So maybe like on the side, write down what all four of these terms are. So f is x cubed minus 5x squared plus 7, and f prime is 3x squared minus 10x. 3 comes down, 2 times 5 is 10. G is your second term, 3x squared plus 6. 2 comes down and we get 6x. Okay, so now we have f times g prime plus g times f prime. So my f term, so all the terms we need are here, which is why it's good to organize it. So we have x cubed minus 5x squared plus 7 times my g prime, which is 6x, plus my g, which is 3x squared plus 6, times my f prime, which is 3x squared minus 10x. Now from here, we do have to FOIL or multiply, distribute. So like in the first case, the 6x is going to get distributed to all the terms in that first parentheses. But in MyOpenMath, we can leave our answer like this in this unsimplified format. We could take it one step further and distribute this, FOIL that, but in the case of MyOpenMath, we can leave it like this. Okay, here's another example. We're given that f of x equals to x to the 10th h of x. We're told that h of negative 1 equals to 4, and we're told that h prime of negative 1 equals to 7. We want to calculate f prime of negative 1. Now notice that f of x is made up of two different terms. It's made up of x to the 10th and h of x. So that is the product rule because we have two different terms that are being multiplied. So we're going to call, instead of f and g, I can use whatever terms I want. But because I already have an f here, I'm going to use a and b instead of f and g. But it's the same formula. So I'm going to say f of x equals to x to the 10th times h of x, where a is x to the 10th and b is h of x. The product rule states that if I want to take f prime of x, because if I want to calculate f prime of negative 1, I first have to know what is f prime of x. That's equal to a times b prime plus b times a prime. It's the same formula. It's the same like f of x times g prime of x plus g of x times f prime of x. Same thing except I'm using a and b. Okay, so we have a times b prime plus b times a prime. So my a term is x to the 10th and my a prime is 10x to the 9th. Now b is h of x, and because I can't do much with that, my b prime is just going to be my h prime of x. So that's what I have to replace b and b prime with. Okay, so my a is x to the 10th, b prime is h prime of x, plus b, which is h of x, times a prime, which is going to be 10x to the 9th power. So it's super important to have all of your information organized. Okay, now what are we looking for? Well, we're looking for f prime of negative 1. So every time I see an x, I'm going to replace the x with a negative 1. Remember, my input replaces every x. So instead of x to the 10th, I have negative 1 to the 10th. Instead of h prime of x, I have h prime of negative 1 because x is negative 1. Instead of h of x, I have h of negative 1. And instead of 10x to the 9th, I have 10 times the parentheses negative 1 to the 9th. Now this is a super important rule, but anytime you replace the x with a number, always use a parentheses. Otherwise, you might get an error due to the negative sign. Okay, so from here, we're going to simplify this. Negative 1 to the 10th is just 1. Now, h prime of negative 1, we're told up here, is 7. So we're going to replace h prime of negative 1 with 7. H of negative 1 is 4, so we're going to replace h of negative 1 with 4. Now, negative 1 to the 9th power is negative 9, and 10 times, sorry, negative 1 to the 9th power is negative 1, and 10 times negative 1 is just negative 10. So now I can multiply 1 times 7 is 7, 4 times negative 10 is negative 40, and that's going to subtract to negative 33. And just remember that if you have negative 1 to the 10th power, that is equal to positive 1 because you're multiplying a negative 1 10 times, an even number of times. Whereas if you have negative 1 to the 9th power, you're multiplying negative 1 an odd number of times, and that'll give us a negative 1. So just a quick reminder. Okay, so next, find y prime by applying the product rule. So first, I'll call the first term f, the second term g, and my y prime is going to be f times g prime plus g times f prime. So on the side, let's list out all 4 of the terms we need. My f is 7 minus x squared, so my f prime is negative 2x. The derivative of 7 is 0, and if I bring the 2 down, it gives me a negative 2x. G is x cubed plus 4x plus 2, so my g prime, if the 3 comes down, is 3x squared plus 4. Now I can just plug all this information in. My f is 7 minus x squared times 3x squared plus 4. So that's my f times g prime, and all that information is here, my f and my g prime, plus g, which is x cubed plus 4x plus 2, times my f prime, which is negative 2x. Now just be aware that my Open Math will accept this as an answer, but in a, like let's say, Calc 2 class, you might have to actually go through and like distribute and combine like terms and all that kind of good stuff. All right, and that's it. Please come to class with questions and having your notes copied down, and I'll be more than happy to answer all the questions you have. Thank you, guys.